Okay, in this video, we're going to do some applications of hypothesis testing. You will be able to use StatCrunch throughout. So I'm just going to use StatCrunch focusing on the p-value approach. There are some videos in the My Course Shell and Moodle and how to work with the critical value approach. However, I will not be imposing the method on you. So if all of you would like, just to use the p-value approach using StatCrunch, that would be perfectly fine. Okay, let's begin. We're going to test the population mean first. A nutrition label says a drink contains 50 milligram of caffeine. You believe it is more. You can pause here and write the null and the alternative hypothesis. More means more than 50. So that would be the alternative hypothesis. And this is where your claim is, right here. Okay, so I'm just going to type claim. And then the null hypothesis will be equal, or for some other books will be less than or equal to. It's the same statement. So now he's going to give us a sample and give us information about the data in the sample. A sample of 22 drinks. So N is 22. That's the sample size. Has a mean of 52 milligram. That's the sample mean. X bar, X with a horizontal line on it. 52. And a standard deviation of 3.5. That's the sample standard deviation. S equals what? 3.5 milligram. Test the claim. Okay, so we need to test the claim at the 5% significance level. So let me just put the question here. Test the claim at the 5%. So the level of significance alpha is 5%. What claim are we testing? We're testing that you believe it is more than 50%. Okay, here's why. Since he gave us sample information, he gave us the sample size, he gave us the sample mean, he gave us the sample standard deviation, we're going to be using t-stats. You're going to see before t-stats, there is a z-stats. The only time you use z-stats if he gives you the population standard deviation. For example, if this question was rewarded like a sample of 22 drinks has a mean of 52 milligrams, and we assume that the population standard deviation is 3.5, in this case you must use z-stats. But since he's referring to the sample here, you just use t-stat. Okay, let me show you how to do that in StatCrunch. So you go to stat, t-stat, one sample with summary, and let me show you here. Okay, I'm gonna drop this a little bit down so you can see it. Okay, you don't see it because, let me see if I can lower this a little bit so you can see the screen. Okay, yeah, probably now. There you go. Sample mean, what is it, 52? Sample standard deviation. Let me just look and make sure we got it. So 52 and 3.5. Okay. 3.5. Sample size is 22. Now perform hypothesis for mean. We're testing against 50. See, it's the same number in the null and the alter. What we're testing, we want to test if the mean is more than 50. Okay, let me just show you one more time. Oh, sorry. Right here. You see, that's the claim that we are testing, that the mean is greater than 50. And if you want to see the p-value in action, guys, I'm going to show it to you. P-value plot. And then you just hit compute. And let me bring this right here so you can see what we're doing. And look. P, this is the test statistic. This is when you convert, just a sample mean to a z-score or t-score in this case. It is 2.68, which is kind of an unusual. Remember, Anything above 2 is considered unusual. Unusual means unlikely to happen, means the probability is going to be low. And look at this probability, guys. It's 0.07. It is low. Now, what is the p-value in technical terms? The p-value, since we have a right tail test, if it is a greater than, we call it a right tail test. The p-value is the area to the right of 2.68. Let me show it to you. You see this number here is 2.68. And look, this is the p-value right here. The one that's shaded in red. Okay, and look, he put it here, 2.680 and 0.07. So if we go back to our document, let's continue here, click compute. So we have, so the p-value is 0, the test statistic is 2.680, you put it here. The p-value is 0.07. And let me just write some interpretation here. So p-value equals 0.007, which is less than alpha, the level of significance. What did we say, guys? If the p-value is less than alpha, we reject HO. And since the claim is in H1, remember what I said earlier in the first video. If the claim right here, you reject this guy, you're saying HO is bad, that means H1 is good, then you support the claim. You say there is enough evidence at the 5% level of significance to support the claim that the drink contains more than 50 milligram of caffeine. And this is the conclusion of this example. Next example. And look, I showed you the steps. If you want to go through the paper, these are the steps in how to use StatCrunch. And we're going to begin with example 2 now. Example 2. I'm giving you the data set in example 2. The company claims that their light bulbs last 1200 hours. So they said the mean lifetime of a light bulb is 1200 hours. You collect data from 12 bulbs. The data is given below. The question is, that's the claim. Okay, so as I said, we have a company that claims that their light bulbs last 1200 hours. We collect the data from 12 bulbs, and then we don't believe that the company's claim is correct, so we need to study, we need to verify, just that. So what would be the null and the alternative hypothesis? The null will be the mean equals 1200, and the alternative will be the mean is not 1200, because they have to be competing hypotheses. And your claim is not, because you believe that this is not correct. And he's asking us to use a 5% level of significance. Here's how we do this one using StatCrunch. First of all, you have to put the data into StatCrunch. So you can see the data is already there. And then we're going to go to stat. If he gives you a data set, guys, you go to T-stats right away. So T-stats, one sample, but not with summary, with data this time. And let me just show you the whole thing. You don't see the entire screen, so let me just lower it a little bit. Okay, we need to select the data, so it's in variable 4. And now, guys, we're gonna do against what number? 1200. And I want to show you the p-value. Here, the p-value, since we have when it is not equal in the alternative, we call it a two-tailed test. Something on the right and something, it could be to the right, it could be to the left. So you're going to see the p-value on both sides. I'm going to do a p-value plot right here and hit compute and watch, guys. This is the test statistic, negative 1.855. And the p-value is 0.0905. Let me go back to the Word document and write him down. So Step one, guys, this is it. We already put it right there. That's step one. Step two, write down the value of the test statistic, which was negative 1.855. Step three, the p-value, which was 0.095, and let me just show it to you again. Or 0.905. I'll change this one and negative. And you want to see the p-value in action, watch. You're going to see it on both tails. Half of the p-value is on this side and half of it on that side. And this one is going to be 1.855 and this one will be negative 1.855. This should be as well shaded because if you have a two-tailed test, half the p-value will be on this side and the other half will be on the other side. Look, this is what you need from StatCrunch to write it down. You need T and you need p-value. Step number 2 and step number 3. That's all you need from StatCrunch. So 0.0905 right here. Okay, guys, alpha is 5%. You agree with me that p-value is bigger than alpha, so we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you start always with there is not. Reject the null hypothesis, there is. Fail to reject the null hypothesis, there is not. Enough evidence at the 5% level of significance. 2. If you're doing your homework online, you're going to have two choices now. Do you use the verb support or the verb reject? Remember, if the claim is in the alternative hypothesis, we never use the word, just reject, we use the word support. So there is not enough evidence at the 5% level of significance to support the claim that the mean lifetime of a light bulb is different from 1200 hours. Okay? That's testing the mean when he gives you a data set. Now we're going to learn how to test the proportion. You suspect more than 65% of students prefer online classes. So what would be the null and the alternative? The alternative will be P more than 65% right here, and that's the claim, guys. And the null hypothesis will be equal, and if you are on-campus students will be less than or equal to 0.65, but both statements are correct. So we need to test the claim that the proportion is more than 65%. In order to test the claim, you need the number of observations, how many in the sample 250, how many successes, 172, this is called X, and 250 is called N, and we need the significance level, which is 5%. Let me show you how to do that in StatCrunch. Okay, we're going to close this one. You go to Stat, you go to Proportion Stats. So when you are testing the proportion, guys, this is the only feature that you need. One sample with summary. Most of the time it is with summary. And let me just reduce the size of this one so you can see the whole thing. Number of successes, 172. Usually this is the smaller number of observation is the sample size, 250. What we are testing against, guys, 0.65. And what is the alternative hypothesis? We say, let me show you again. We need to test that P is greater than 0.65. So greater than, I need to choose this one. And then I'm going to show you the p-value in action. It's going to be an area to the right because it's greater than, so it's a right tail test. Compute, and let me get this inside. And look, guys. You need Z and you need the p-value. This is called the test statistic. So you need the last two, guys, always the last two. Here, the test statistic is called Z, which is 1.26 if you round it to 2 decimal places. And the p-value is huge. It's bigger than 5%. So let me show you the shading. You're going to see that quite a bit is shaded right here, you see. And this is the Z-stat, 1.26. We round it to 2 decimal places. So let me just, p-value again, 1.26 and the p-value 1039. Okay. So let me just write down the details. So step 2, Z equal 1.26. Step 3, p-value equals 0.1036. Is that correct? That's what we got. 1039, sorry. 1039. Step 4, compare the p-value with alpha. You know 0.1039 is bigger than 0.05. So p-value is bigger than alpha, which is 0.05. So what's the decision, guys? We fail to reject HO. Conclusion. Step 5. Since we fail to reject HO, we start with there is not enough evidence at the 5% level of significance to support. Why I use the word support? Because the claim is in HA right here, or H1. To support the claim that more than 65%, I just copy it and paste it from the problem itself. Let me show you the question. More than 65% of students prefer online classes. You are not supporting the claim here. You are saying we don't have enough evidence to support the claim. That means you are not supporting the claim. When you don't support the claim, so probably HO is correct. It could be because you could not support the claim, which turned out to be in H1. So these are the 3 examples that you can follow throughout the chapter to perform hypothesis testing. And quickly, guys, you're gonna need one of those 3. Either z-stats, we only use z-stats when the population standard deviation is given in the problem. If he says in the example or the problem he gives you, assume that the population standard deviation is, let's say, 10.5, then in this case you must use the z distribution. If he doesn't, which is likely the case, he gives you the sample standard deviation, it is, and he wants you to test the mean, it is a t-stat. So you go t-stat, one sample, either with data or with summary, and just go from there. But if he is asking you to test the proportion, P, you don't use Z stats, you don't use T stats, you use proportion stats. One sample with summary, you put the number of successes, you put the number of observations, you state the value in the null hypothesis, and then you go from there. Here, number of successes is X, number of observations is N, and then whatever we're testing against in the previous exercise was 0.65. Don't forget to put the correct sign in the alternative. And guys, you can hit compute, and that should give you the tested statistic Z and the p-value. I hope that this video helps a bit grasping the concepts of this very, very important chapter.